Hello, Professor. This is Sudeepto Hasan, ID 1014711720, and here is my assignment. First of all, I have imported Google Drive here. Second, I have import a file CSV file as Panda SPD and give that CSV file here in my Google Drive. Third, here I've done the content I said this file and variable name Irish, so I've saved here as Irish. And once you question, I've shown the first 5 row of the data frame. And next, convert the last column. So I've done some work here. You can see after check the first 5 once again. So you can see the species values has become 0. In question 3, given the first 4 column of the data, and second question I have done the select the last column level and call it y, so I've called it y, and here I've called it x, and I have import some data set here. Split the data and leveling into training and testing segment, while the size of the data is 20%, random state is 1 to 3, and make all the answers similar to the whole class. So I have done this here, giving 20% and random state 1 to 3. And number 4, we check the first 5 rows of the X train, X test, X Y train, Y test data set. So here you can see 5 rows of the X train, X test, Y train, and Y test. So afterwards, I've checked the X train and X test length, which the number is 120 and 30. Awesome, we're going to continue. So you can see it's 120 and 30 for the X train length and X test length. So in another question, I've done, converted the Y18 and Y test from categorical one hot encoded values and call them one hot train level and one hot test level here. So in another question, define a sequential model's density layer. So according to the question, there is the answer. Next, now compile your model using the RMS prompt optimizer as an appropriate loss function and accuracy for your metrics. So I have done the Keras losses here and use the optimizer RMS prompt. So and after that I've trained my model using epoch and batch. Here it's, you can see number 8A is calculate the result evaluating the X test and one hot test level and report accuracy of your model. So you can see I've calculated the result here. Uh, so number 9A, now we repeat all we have done in 06 with the following parameters. Here you can see the number 9 answer here. 9B is the same setting for the 9B 6B compile using the same optimizer loss function and output the accuracy. So here is the question 6B. And I have fitted my model using epoch 4 and batch 10. You can see here I fitted my model here, and I've calculated the result here evaluating X test and one train. So you can see the test loss and test accuracy. So here I have to answer some questions at a minimum. So how the number layer hit and input accuracy for model, do we always suffer from overfitting, and how do we detect overfitting, and how do we reduce so increasing the number of hidden layers or unit in the model can improve ability to capture complex relationship. We can lead to higher accuracy. However, adding too many layers on the neuron may result in overfitting, where the model learns to memorize the training data instead of generalizing from it. So this overfitting negatively impacts the model's performance on new unseen data, and it will cause a high accuracy on the training set but low accuracy on the validation or test set. So this is number. So do you always suffer from overfitting, or how can we detect overfitting? So overfitting occurs when a model becomes too complex and start learning noise or irrelevant patterns of the training data. Then the underlying traits model overly feel perform well training about but poorly on validation or test data. So how we can reduce overfitting? So we can reduce the model complication by removing layers or reducing the number of neurons in the hidden layer, and apply L2 regularization, which penalize large weight values to prevent from model becoming the complex and memorizing the training data. Number three, use dropout, which randomly drops neuron during training to prevent the model from relying too heavy on specific neurons or feature, and increase the size of dataset or use augmentation techniques to provide more diverse example for the model, improving its ability to generalize, and use early stopping to halt the training process when the model's performance on the validation data begins to degrade, preventing the model from overfitting the training data. And in the last question, you can see it is given that use different setting than the ones we choose in number 9. So here is the answer number 9. So yes, that was my assignment to Professor. Thank you so much and have a good day.